All right, guys, this week we're going to get back to regular math. We're going to cover 3 topics, but just the basics of them today. And they're going to be simplifying, multiplying, and dividing rational expressions. So you guys already know how to factor. So that's the hardest part of this, is being able to factor, because before you can do any simplifying, you have to factor the expressions completely, and then you can simplify anything that is the same in the numerator and denominator. Okay, so we're going to start with this first example, 4x squared minus 20x over x squared minus 14x plus 45, and start by factoring this out. So in the numerator, we can take out the GCF, which is 4x. So I'm going to pull out 4x, and then what's left over when I pull out a 4x from the first part is just an x, and from the second part you're dividing, so that would leave you with a minus 5. In the denominator, you're factoring this into 2 binomials. Figuring out what multiplies to 45 that adds to negative 14, and that would be a negative 9 times a negative 5, and that'll add to negative 14. So we'll put x minus 9, x minus 5 here. Now that you have it in factored form, now you can look for things that are common and cancel them out. So we can cancel this x minus 5 with this x minus 5. Now, a common mistake that's usually made here is canceling the x with the x, and you cannot cancel those 2 x's. And the reason is that anytime the x is connected to something else using a plus or minus sign, you can't think of them as 2 separate pieces. You can only think of them as one whole thing. So the final answer here would be 4x in the numerator and x minus 9 in the denominator, and you can't do anything else with that. So that would be it, 4x over x minus 9. I have an explanation for that further that I would usually do in class. So if you don't understand why you can't cancel further, come to one of my help sessions and I can explain that further. All right, we're going to do one more with simplifying. We have x squared plus 2x minus 15 over x squared minus 9. Okay, so we're looking for something that multiplies to negative 15 and adds to positive 2. Okay, so that would be a positive 5 times a negative 3. So that breaks into x plus 5 times x minus 3. In the denominator, this is one of our special binomials. It's a difference of squares. Remember that anytime you have a perfect square and another perfect square separated by a minus sign, these are those special ones that factor into opposites because you're trying to make 0 in the middle. So you're trying to multiply to negative 9 and then add to 0 because there's nothing in the middle. So that would be a positive 3 times a negative 3. That would give us a 0. So plus 3 minus 3 here. And once it's in factored form, you can go ahead and cancel like quantities out. So I can cancel out the x minus 3's, which leaves us with a final answer of x plus 5 over x plus 3. You do not need the parentheses anymore in the final answer since that's all that's left. You only need these parentheses when there's other stuff there. So since x plus 5 is the only thing that's left, we can drop the parentheses. Okay, so that's how you do the simplifying. Now let's move on to multiplying. Okay, so the first example we're going to do with multiplying is 3x squared over x squared minus 100 times x plus 10 over 3x. With multiplying, it's almost identical to simplifying. It's just two separate fractions. So multiplication can be thought of as one gigantic fraction. So even though they're separate, you can still cancel a numerator with a denominator even if they're not part of the same fraction. So we're going to do the same exact way we just did with the simplifying, and we're going to start by factoring. So the 3x squared is a monomial. Monomials cannot be broken apart, so we're just going to leave that the same. The denominator is another difference of squares, just like that last one we did. So we want to multiply to negative 100 and add to 0. So that's 10 times negative 10. So that's x plus 10 times x minus 10. Now the second fraction. We have x plus 10 in the numerator, and that linear term, when we don't have an exponent, is not going to be able to be broken apart unless there's a GCF. And x plus 10 cannot be broken apart because it does not have a GCF. The 3x is another monomial, so we'll just leave that alone. And now we can look for things that can cancel. So like I said, even though this x plus 10 and this x plus 10 are part of two separate fractions, you can still cancel them because one of them is in the numerator and one of them is in the denominator. If they were both part of denominators, you would not be able to do that. They do have to be in opposite places. All right, we can also simplify these monomials because when there's no plus or minus sign connecting things, you can cancel pieces. So I can cancel this 3 with this 3. And I can cancel this x with one of these x's, leaving us with just an x up there. Okay? So once everything drops out, let's look at what we have left. This dropped, this dropped, this dropped. We still have an x left in the numerator. In the denominator, this dropped and all this dropped. So we just have this x minus 10 in the denominator. All right, Tyler. Tell me if you're able to cancel these two x's here. No, you're right. You can't. You can only cancel them if that minus sign weren't there between the x and the 10. So this is your final answer. Great job, Tyler. All right, let's do our next multiplying. Now this looks really scary, but it's really not that bad. You know, it looks ginormous. But once we break it all apart, all kinds of stuff is going to cancel and we're not going to have much left. Okay, so let's start with the numerator of the first fraction. We want to multiply to 12 and add to 7. So that would be 4 and 3. So x plus 4 times x plus 3. Let's go underneath that. We want to multiply to 20 and add to 9. Hefe? Right on. 5 times 4. Alrighty. The next one. 3x plus 15. What can we do there, Sammy? That's right, you can take out a 3. All right, take out a 3. Remember to put that 3 out there. Don't drop it. You have to account for it. You can't just drop the 3. So we put the 3 on the outside and we're left with an x plus 5 on the inside. All right, and the last piece, we want to multiply to 3 and add to 4. Let's see. Mac, what multiplies to 3 and adds to 4? Right on, 3 and 1. X plus 3 times x plus 1. Alrighty, let's go ahead and start canceling some things out. So remember, they don't have to be part of the same fraction, but they can be part of the same fraction. So this x plus 4 and this x plus 4 can cancel because one is in the numerator and one is in the denominator. And this x plus 3 and this x plus 3 can cancel because one is in the numerator and one is in the denominator. And the x plus 5s can cancel. So the only pieces that are remaining, we have a 3 in the numerator and an x plus 1 in the denominator. And that would be it for that problem. All right, now the last piece of all of this is dividing, and dividing is the hardest. The reason that dividing is the most difficult is because you have to do an extra step on it. You have to remember that you can't divide two fractions. You have to actually change the division to multiplication and flip the second fraction. What do we call that when we flip a fraction? Tommy? That's right, reciprocal. So we're going to take the reciprocal of the second fraction and we are going to change this to multiplication and leave the first fraction alone. So I like to call this keep, change, flip. And if you guys take Algebra 3 next year with me, I will explain that further in that class. I would normally do this in school also, explain why we have to keep, change, flip. But for the sake of keeping things simple, I'm just going to show you how to do it. All right, so we're going to keep the first fraction the same. So we're going to leave that x squared plus 6x minus 27 over x plus 9. Now we have to change the division to multiplication. And then we have to flip the second fraction. So we're going to put the x squared minus 9x plus 14 over the 3x squared minus 9x. Now, the great thing about this is that you already know how to multiply two rational expressions, and now it's a multiplication problem. So it's just like what I just showed you. So the first fraction, multiply to negative 27, add to 6, and that would be a positive 9 times a negative 3. So x plus 9 times x minus 3. Abby, what can I do with this x plus 9 in the denominator? That's right, nothing. We're just going to leave it the same. Connor, how about the second fraction? What multiplies to 14 and adds to negative 9? Negative 7, negative 2. Good job. And then the denominator, 3x squared minus 9x. Let's see, who can I call on? Tanner. 3x, that's right. We're just going to pull out a 3x. That's a GCF. So we'll be left with x minus 3. All right, now that it's all factored, now we can cancel stuff again, just like in the last two sets of problems. Cancel the x minus 3s, x plus 9s, and that's it. Now, I'm not going to make you guys multiply these back together. You can just leave them factored. So x minus 7 times x minus 2 can remain in the numerator, and parentheses are necessary there because we have two pieces. And then in the denominator, we can just bring over the 3x. And that's it for that problem. All right, just one more, guys, and then we'll be done. All right, last one. Again, as soon as you see division, you know you have to keep, change, flip. So keep the x squared minus 49 over x squared minus 8x plus 7. Change the division to multiplication and flip the second fraction. All right. What can I do? What can I do? Alyssa, what can I do with the x squared minus 49? What's that called? Right, it's a difference of squares. You can use -7 and +7. X minus 7 times x plus 7. All right. Mason, how about the x squared minus 8x plus 7? You can break that into a -7 and -1. Excellent. All right, second fraction. Caitlin. That's right. Pull out a 2x and leaves you with an x plus 5. And the last piece. Who's getting the last piece of this? How about Cheyenne? 7 and 5. Good job. All right, now let's cancel some things out. We have an x plus 7 and x plus 7, x plus 5, x plus 5, x minus 7s, and all that's left is a 2x on top and an x minus 1 on the bottom. And there you go. Hopefully you made it through this entire video, because I'm going to tell you that since the governor has ordered that we have Spirit Week this week, if you send me a picture of you in your pajamas tomorrow, you can eliminate 2 problems from your assignment. You had to have watched the whole video to know this. So you can eliminate 2 problems from your assignment if you send me a picture of you in your pajamas tomorrow. Okay. Talk to you later. Peace out.